Welcome to the world of C++ numeric algorithms. In this video, we will explore the mathematical operations that can be performed on ranges of elements within the Standard Template Library, or STL. These algorithms provide efficient and concise ways to perform calculations such as accumulating values, computing inner products, calculating differences, and performing partial sums. Let's dive in and see how these powerful tools can simplify your numerical computations in C++. Let's start with STD. Accumulate. The accumulate algorithm computes the sum of a range of elements. You can find it in the numeric header. It also allows the use of custom binary operations. Takes an initial value as a starting point. Here's an example. First, include iostream, vector, and numeric headers. Then, in the main function, create a standard vector of integers named numbers, initialize with values 1, 2, 3, 4, and 5. To sum all elements, declare an integer variable named sum, and assign it the result of std. Accumulate. Pass numbers.begin, numbers.end, and 0 as arguments. Finally, print the sum to the console. This code calculates the sum of all elements in the numbers vector and prints the result. Now let's explore how std. Accumulate can be used with custom binary operations. Instead of just addition, you can use multiplication, string concatenation, custom functions, or even lambda expressions. Consider this example where we calculate the product of elements in a vector. Include iostream, vector, numeric, and string headers. In the main function, create a standard vector of integers named nums, initialize with values 1, 2, 3, 4, and 5. To find the product of all elements, declare an integer variable named product and assign it the result of std. Accumulate. Pass nums.begin, nums.end, 1 and std. Multiplies int as arguments. This code computes the product of all elements in the nums vector using std, multiplies and stores the result in the product variable. Next up is std. Inner_product. The inner_product algorithm computes the sum of products of corresponding elements in two ranges. Common applications include the dot product of vectors, matrix operations, and weighted sums. Here's how it works. Include iostream, vector, and numeric headers. In the main function, create two standard vectors of integers v1 and v2. Initialize v1 with values 1, 2, and 3, and v2 with values 4, 5, and 6. To compute the inner product, declare an integer variable named result and assign it the result of std. Inner_product. Pass v1.begin, v1.end, v2.begin, and 0 as arguments. Finally, print the result to the console. This code calculates the inner product of vectors v1 and v2, starting with an initial value of 0, and prints the result. Let's move on to std. Adjacent_difference. The adjacent_difference algorithm computes the differences between adjacent elements in a range. For each element except the first, it calculates the current element minus the previous element, storing the result in the output range. The first element is copied unchanged. Here's an example. Include iostream, vector, and numeric headers. In the main function, create a standard vector of integers named values, initialized with values 2, 4, 6, 8, and 10. Create another standard vector of integers named differences with the same size as values. Call std. Adjacent_difference, passing values.begin, values.end, and differences.begin as arguments. This code computes the adjacent differences of the values vector and stores the results in the differences vector. The result will be that the differences vector contains the values 2, 2, 2, 2, and 2. Now let's explore std. Partial_sum. The partial_sum algorithm computes the running total of elements in a range. For each position I in the output range, it calculates the sum of elements from 0 to I. This is also known as the prefix sum or cumulative sum. It can also be used with custom binary operations. Here's how: include IOStream, vector, and numeric headers. In the main function, create a standard vector of integers named values, initialized with values 1, 2, 3, 4, and 5. Create another standard vector of integers named sums with the same size as values. Call std, partial_sum, passing values.begin, values.end, and sums.begin as arguments. This code computes the partial sums of the values vector and stores the results in the sums vector. The resulting sums vector will contain the values 1, 3, 6, 10, and 15. Let's look at std, reduce. Introduced in C++17, the reduce algorithm is a parallel-friendly version of accumulate. The order of operations is not guaranteed, and it supports execution policies. It requires associative operations. Here's an example. Include IOStream, vector, numeric, and execution headers. In the main function, create a standard vector of integers named values, initialized with values 1, 2, 3, 4, and 5. To perform a sequential reduction, declare an integer variable named sum1 and assign it the result of std. Reduce, passing values.begin, and values.end as arguments. For a parallel reduction, declare an integer variable named sum2 and assign it the result of std. Reduce, passing std. Execution, par, values.begin, and values.end as arguments. This code demonstrates both sequential and parallel reduction of the values vector using std. Reduce. In summary, we've covered several key algorithms. Accumulate, which sums or combines elements. Inner_product, which multiplies and sums elements. Adjacent_difference, which computes differences. Partial_sum, which computes running totals. And reduce, a parallel-friendly accumulation. These algorithms have common applications in statistical calculations, financial computations, signal processing, scientific computing, and data analysis. Here are some best practices. Use appropriate initial values, such as 0 for sum and 1 for product. Consider numeric limits for large datasets. Use execution policies for large collections. Ensure operations are associative for parallel algorithms. Check for sufficient output container size. Finally, consider custom operations for complex calculations. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.